Hello, and welcome back for another installment of our look at the math contest, this time a solution for the May the 7th problem of the week. What is the millionth term in the sequence 1, 2, 2, 3, 3, 3, 4, 4, 4, 4, and so on? Alright, I love these kind of problems. It's definitely true that the more of these kind of problems you solve, the more familiar, the more comfortable you're going to be with tackling new versions of them. Uh, Something like this where it goes way out, obviously you could do what they call a brute force method and truly list them all out, but you might make yourself crazy. And a lot of times these yield to clever solutions. So the first thing that I would do when approaching something like this is try to find some pattern that I can exploit and use to let me compute way out into the distance without actually having to do the counting. So the first thing I'm going to look at for this kind of a solution is uh, where is the transition between digits? Is there some kind of a pattern I can use there? For instance, the 1 is the first digit, and then on the second digit we change to 2, and on the fourth digit we change to 3. So let me pull up a sticky note here. On the 1 we change to 1s, on the second digit we change to 2s, on the fourth digit we change to 3s, and I'm starting to get excited. I'm saying, maybe I see a pattern here. Then on the seventh digit I change to 4s. That's not as nice. I'm not really seeing anything great here. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. On the 11th digit we change to 5s. I don't know. That's not exciting me. So then instead I'm going to look at a different thing. The 1s reach to the first digit. Now the 2s reach to the third digit. Right? And what I mean by that is 1, 2, 3. And then the 3s reach to 4, 5, 6. So the 3s reach to 6. The 4s reach to 10. Oh, now I'm getting excited. And of course this is going to be more familiar to you if you've taught math, if you've studied math, if you play these kind of games or puzzles or work through these problems. 1, 3, 6, 10, they have a name. Those are what we call triangular numbers. In fact, these were used in a previous solution not so long ago. So now that I know I'm looking at triangular numbers, let us create a little function. We'll call it T for triangular numbers, and we are going to follow this pattern. So this is the function that generates triangle numbers. And if you want some verification, let me just show you. The first triangular number is 1, the second is 3, the third is 6, and yes, the fourth is 10. So we've kind of confirmed that the triangular numbers are going to tell us how far. For instance, the triangular number 1 tells us how far the 1s reach. 2 tells us how far the 2s reach to the third term. And the 3s reach out to the 6th term, and the 4s reach out to the 10th term. So just by using this, we can see how far these numbers reach out. Now the question is, we want to see what number reaches out to 1 million. So what we're really looking at is what number do I put here inside the function to get 1 million. And as on so many other problems, this is going to be really useful to employ CAS and just have it solve this equation for us. So I'm going to say solve T of n. I want to know when that is going to equal 1 million. Oh, I probably need to tell it that n is my variable. Yeah. It'll automatically assume x is your variable. Since I'm using n, you have to tell it n is your variable. Ooh, that's ugly. That doesn't seem very helpful immediately. But what if I toggle that to decimal form? Aha! So it turns out that 1413.7 gets me to 1 million. Just to be set, actually, you know what we can do? We can say, when is this going to be We want to know when we reach beyond a million. So I could even say greater than a million. And then it'll tell me that in order for that to be the case, n must be greater than 1413.7. So I already suspect that the next digit that's going to solve this for me is going to be 1414, because I want n to be bigger than that. But just to be totally safe, let's just take a quick look. What if I had 1413 and that doesn't quite make it to a million? And so we know that 1414 should extend well beyond a million. And so that is going to be the number that we're looking for. So what is the millionth term in the sequence? It should be a bunch of 1413s, and then we transition to 1414, and they reach well past a million. So we know that that millionth term is somewhere in the middle of this list of values. Awesome. I'm sure there's other ways of doing this, but hopefully that's one way that you find interesting and or useful. Thanks as always for your time and attention, and we'll look for you again in a future video.